Good morning, everybody. So, you have made it to simulations and predictions. So, just like the other videos, you're going to kind of follow along and then you'll have some to do independently. So, you'll probably hear the dogs in the background at some point, but we're used to that now. Okay, so let's go ahead and get started. I'm going to click on my pen and then get rid of this right here. Okay, so simulations and predictions. In order to obtain the probability of various events, a simulation is often conducted. And you guys know what a simulation is. It's kind of like reenacting something or enacting something. It allows us to represent the likelihood. So please put, uh-oh, my pen's not working. Well, maybe I can draw. Yeah, there we go. Likelihood. Yep, this is going to be messy. I'm using my finger because the pen is not working. The likelihood of an event occurring by using an experiment with similar probabilities. So similar probabilities. Yep, that's messy. This says similar probabilities. This method is used by researchers when it is difficult to collect experimental data or when the theoretical probability is unknown. So a good example, actually several examples, we could say tossing a coin would be one. Make sure you're writing this down. We could say rolling a cube. We could say using a deck of cards. Make sure you write that down. So those are just a couple of different examples of what you could do. So we're going to brainstorm a simulation that could represent the same probability as the following situations. On a multiple choice question, there is a 25% chance of getting the answer correct. Well, let's take what we know about 25%. 25% means 1/4. So you want to think of something that you could have a 1 out of 4 chance. Well, I know that it's not going to be flipping a coin because that's only two sides. I know it's not going to be a deck of cards because there's 52 decks of cards in a deck. So I have to kind of get creative with this. So maybe you're going to want to make a spinner, and the spinner would have 4 sections. I'm going to type this because clearly my writing was not working out well. So you'll be able to copy this better. So an example would be spinning a 1 or maybe a 2 or a 3 or whatever on a spinner with 4 equal sections labeled 1 through 4. So that's my quarters, right? So section 1 is a quarter, section 2 is a quarter, section 3 is a quarter, and section 4 is a quarter. And the probability of me spinning a 1 would be a 1 out of 4 chance, which we know is the same thing as 25%. So that's one idea. You can come up with your own creative ideas if you'd like as well. So number 2, the weather report shows that there's a 50% chance of rain. So 50% means 1 out of 2, 1/2, correct? So what are some things that you could do that are 1 out of 2? Well, this spinner situation that we just did would not work in this situation because there's 4 of them. So this might be a really good time to think about using a coin. So maybe our example might be flipping tails on a fair coin. So we know that that is a 50% chance. You're either going to get tails or you're going to get heads. The next one, an average basketball player makes a 66.6, and that little bar above the 6 means that 6 goes on forever and ever. So what this number really is 66.666666666% of his free throws. So this one's a little bit more difficult because you have to know what 66.66666% actually means. And in this case, I know that 66 point blah, 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 66% is 2/3. So I need to think of something that would be 2/3. All right. What about a dice? A dice has 6 sides. Would that work? Does 6 come out to 2/3? Well, we might have to take that a little bit of a step further. So, our example, and I'm going to explain the reason why this would work. Our example would be rolling a 1, 2, 3, or 4. Oops, back it up. 3 or 4 on a number cube. So here's the reason why. Do you agree that there's 6 sides on a dice? So if I rolled a 1, that's a 1 out of 6 chance. If I rolled a 1 or a 2, that's a 2 out of 6 chance. A 1, 2, or 3, 3 out of 6 chance. A 1, 2, 3, or 4, that's a 4 out of 6 chance. And 4/6, if you look at that fraction, simplifies to 2/3. And if you do the division in your calculator, 2 divided by 3 ends up being that 0.666666666. It goes on forever and ever and ever. To convert that to the fraction or the percent, we know we have to move that decimal 2 spaces, which is where the 66.6 comes from. So there was a lot of different levels of skills that you've learned just plugged into that one to be able to come up with a simulation that would work for this. Number 4, there is an equally likely chance that a baby is a boy or a girl. Okay, so we know that that's 50%. We've already used a fair coin. So what could be something else that you could do that comes out to being 50%? You've got a 1, it's either going to be a boy or a girl. So in this case, I'm going to use a deck of cards. But are you thinking, wait a minute, the deck of cards has 52. That's true. But I'm going to make this very specific. The example is drawing a red card in a full deck of cards. Well, oh, there goes the dogs. Yep, knew that was happening. Let's pause until this psychoness goes away. Okay. So back to this. The reason why we can say a red card is because, yes, even though there's 52 cards in the deck, half of them are red and half of them are black. So the chance of you picking a red card is really 1 out of 2. If half of them are red, that means 26 out of the 52 are red. That will simplify to 1/2. All right, here is your job. You're going to use a simulation to determine the likelihood of each event occurring. So you're going to press pause on this video in just a second. You're going to complete all 3 parts of number 5 on your own. If you're sitting by somebody that is at the same point as you can always check in with them. You're creating the simulation just like what we just did. So you have to get creative and get some ideas about what you think could be used. Here's the hint. I don't want you to use the exact same situation that we used before. So if you notice this one says having a boy or a girl, I don't want you using the card example that I use, and I don't want you using the coin example. So I want you to find or develop some other kind of situation that could be used. Once you're finished with this, check with me. I will either approve you or tell you to retry, and then you can resume this video to move on to making predictions. So at this point, pause the video. All right, if you are back with me, this means you got approved on the simulations section of this video. If you did not get approved, you should not be working on this piece right now. If you did get approved, then you are good to go. So we're going to go ahead and keep going here. So making predictions. Probability can be used to make predictions for future, future occurrences by setting up and solving a proportion. So here's an example, and you know proportions. This is equivalent ratios. So it's just called a proportion. And when you get into seventh grade, proportion is going to be the big word that you hear when you're talking about equivalent ratios. And it's going to become a huge part of your seventh grade life. Okay, so the probability of rolling a 6 on a number cube is 1/6. If the number cube is rolled 50 times, then approximately how many times will a 6 be rolled? All right, I'm not going to use the typing feature for this because I need to show you the math. So let's go ahead and do this way. So we want the probability of rolling a 6, which is 1 out of 6. So I'm going to do my 1 out of 6. You're going to do this too. I want to roll that number cube 50 times. So remember, 50 is the total. So that's going to be over here. That's our 50. And I want to know approximately how many times that would be rolled. So I don't know. Oops, that's an X. I don't know what that is right now. So I'm going to have to figure it out. Let's take our mind back to equivalent ratios. I want to find that easy way to get from the 6 to the 50. Now, there really is no easy way to get there. So I'm going to have to go ahead and do the cross multiply. So, and this is just like percents, except we're not an equivalent or solving equations, but we're just not using that 100 on the bottom. So 6 times x is 6x. And 50 times 1 is 50. So now I know I have to find what number times 6 is going to equal 50. So you could go ahead and do this in your calculator if you wanted to, and you would get a decimal, and that's fine. You could also do it as a fraction. So I'm going to do the math off to the side here because I want to show you it as a fraction because that's, not everybody's favorite. So this is going to go in 8 times. That's an 8. 48, 2 left over. This becomes our numerator. So it is 8 and 2/6. This denominator is right here. That's going to simplify to 8 and 1/3 because we divide that 2 and that 6. So I know the probability that if I rolled 50 times, the probability of a 6 being rolled is going to be 8 1/3 times. That doesn't mean it's gonna happen, but the probability of it happening is that much. So I'm predicting that that's going to happen. Okay, let's take a look at our example. So Kinsey surveyed a random group of 7th graders as to whether they preferred video games, sports, or neither. We're going to use the survey results to make a prediction for the entire 7th grade class with 350 students. Okay, so basically, like they said, this was a random group. So it wasn't all 350 students. They pulled a certain amount, and that certain amount comes from right here. So the total that they asked, 15 preferred video games, 22 preferred sports, and 3 preferred neither. So if you add 15, 22, and 30, there were 40 students altogether that this person asked. So I want to know what a reasonable prediction for all of the total number of 7th graders that prefer video games. Okay, so I know the total in the whole entire class is 350 students, but we only asked 40. So we know that 15 of that 40 preferred video games. So I'm going to go 15 over 40. That represents, of the 40 people that they asked, 15 of them prefer video games. So I'm kind of using this to predict what it would be like for the entire 350 kids. So I want to go set up my equivalent ratios or my proportion. 350 is my total. I'm trying to decide how many that might be out of 350. Now, you know you're going to want to look for that pattern, and this one's going to be an ugly one because there's no good way to get from 40 to 350. So there's other ways you can solve. You could simplify if you wanted to early, and that's totally fine. I'm just going to go ahead and do our cross multiplying. So 40 times x is 40x. And 350 times 15 is 5250. You can type that in your calculator if you'd like. So that means 40 times something equals 5,250. Now, you know, to undo this, we need to divide. So in your calculator, type 5250 divided by 40. What you should get is 131.25. Well, this means this is a partial student, right? You can't have 0.25 of a student. So a reasonable prediction for this would just be 131 students. So I'm going to clear this out. If you didn't catch all this, press pause before I clear it or rewind. A reasonable prediction would be 131 students. Okay. Next part. Based on the information in the table, what is the most reasonable prediction of the number of votes for video games in the next 80 votes? Okay, so remember, 15 out of 40. Oh, I hear Gunner barking. 15 out of 40 in this small sample preferred video games. Well, let's set up our proportion. I want to know the next 80 votes. So 80 is going to be the next level, so to speak. We know it's not the total, but it's the next goal that I'm trying to hit. I need to figure out how many that is out of 80. Yay, I like this one because there's a nice and easy way to get from 40 to 80 times 2, which means I do that to my 15. And 15 times 2 is 30. So we can reasonably expect or predict that 30 students of the next 80 that are asked will prefer video games. All right, we're going to do one more together. So I'm going to clear this out. Let's bring this back up. And we're going to look at number 7. And back to my pen. Okay. So Ellie had a package of 15 candies. After opening it, she found that there were 13 candies that were not green. So the package had 15 and 13 of them were not green, which means 2 were green. If she opened 3 more packages of candies, how many green candies could she expect in total? Okay, let's break this down. So we've already decided that 2 out of the 15 are green. So that's 1 package has 15, correct? She opened 3 more packages, and if they have 15, so 15 in that one, 15 in that one, and 15 in that one. So she has 4 packages in total, which means there's a total of 60 pieces of candy. And I want to know how many green there would be. Now, we already decided that this 2 represents green. So you remember from ratios, we got to keep the same thing with the same thing. So 15 was the total in 1 package. 60 is the total in 4 packages. And I know this 2 is green. I'm going to put that doesn't look like a green. Well, okay, that's a G for green. So I'm looking to see how did I get from the 15 to the 60? That is a times 4 pattern. We like that so we don't have to do our cross multiplying, which means I multiply the top times 4. 2 times 4 is 8. And since this was green, that means this is green. I'm really sorry about my writing. I'm doing my best. So 8 green candies is what she can expect. 8 green. All right. Here's your job. Please make sure this is copied down. You're going to complete part A and B for number 8 on your own. Once you finish A and B, you're going to come and check with me. And then if you get approved, you'll move on to the next thing that is in your slides. So let me take this over. Let's see if I can click over. Yep, there we go. So this is where we are, simulations and predictions. After you finish that video, which is what we're doing right now, you'll type in the date that you completed, and if I've approved it, I'll put my initials right there. Then you're going to move on to the simulations and predictions worksheet that's in your packet, which is right behind what you're working on now. Then you are going to do a mastery check. If you still have time or if you're ahead, come see me for the simulations trial after I have initialed here. So please make sure you know exactly what you're supposed to be doing next. If you need to rewatch this little piece at the end here so you know what order to go in, don't come up to me and say, I don't know what to do now, because it's right here. I'm telling you exactly what you need to do next. All right, get to it, kiddos.